I've been out sick the last couple of days. I'm still getting over a cold. I'm not going to post a video for those days because the kids were just multiplying decimals, which was just practice for them. Now that I'm coming back, we're going to start back on dividing decimals. I did not update the title here, but it's dividing decimals. So the warm-up is just more practice of what they've already been doing, which is multiplying decimals. I'm going to go ahead and skip that, make this video a little bit shorter, just get through the essential stuff, which is that we're going to review long division with integers, that means whole numbers, and we're going to perform long division with non-integers, so numbers with decimals, as the dividend, as the thing that's being divided. So first, we're going to look at a mnemonic device for helping remember the steps for long division, which is, does McDonald's serve cold burgers raw? So what this stands for in math is divide, multiply, subtract, compare, bring down, and repeat. Alright, so to take a look at that, first of all, when I have 6,824 divided by 4, the first number goes inside the house, as we call it, which of course is not a very scientific term or mathematical term for this division sign, but it gets the point across. The first number, or if you have a fraction, the top number, goes inside the house because it is the thing being divided. So then I go to, well, the first step, divide. Does 4 go into 6? Yeah, it will go in one time. And then I go to multiply. 1 times 4 is 4. And I go to subtract to get a remainder of 2. Then I go to compare, and I have to make sure that my remainder is smaller than my divisor, or else I didn't make it go in enough times. So because 2 is smaller than 4, that's good. I can keep going. So we get 28. When I bring down my 8, that's 28. Let's do an example of where compare will help. Let's say, well, 4 will go into 28 6 times. And 6 times 4 is 24. And then I have 4 left over. Well, when I compare, I see that 4 and 4 are the same. So it could go in at least one more time, so I didn't do that quite right. And this would mess us up when we go to bring down the 2, because 4 goes into 42 10 times, and you'd, like, where would you put that 1 and the 0? So what I need to do is back it up and say, well, 4 actually goes into 28 7 times. 4 times 7 is 28. Nothing left over. Now I can bring down my 2. 4 doesn't go into 2, or rather it goes in 0 times. Subtract, compare, it's smaller, bring down. 4 goes into 24 6 times, and we already did that one earlier. There's nothing left over. Because there's nothing more to divide and there's nothing left over, I can stop. So 4 goes into 6,824 1,706 times. Doing it with decimals is similar, but we're going to add in an estimate first to help us figure out where to place the decimal. So this is 3.45 divided by 5. So it's something less than 5 being divided by 5, so my estimate is that it's going to be less than 1. Maybe not hugely less than 1, because this is only a little less than 5, but less than 1. So then when I solve it, it's 345 divided by 5. 5 doesn't go into 3, but it does go into 34 6 times. 6 times 5 is 30. That's my multiply. Then I need my subtract step. Compare, 4 is smaller than 5, so I can keep going. Bring down. And repeat. 5 goes into 45 9 times. 9 times 5 is 45, and when I subtract, I get 0, and I can stop because there's nothing left to divide. So I got 69, but obviously it was 3.45 divided by 5. So and my answer needs to be slightly less than 1, so if I put the decimal right here, then it would make sense. 0.69. And when you look, that's actually where the decimal was in the problem, which is not a coincidence when you're dividing. Okay, the next section has a slightly different type. This is what happens when you have a remainder. So first I'm going to estimate. 24 divided by 6 would be 4. Of course, it's going to be a little more than 4 because this is a little more than 24. And then I get, well, 6 goes into 24 4 times. 6 doesn't go into 3. But I need to be able to keep going. So my decimal's right here. What if I, instead of doing 6 into 3/10, did 6 into 30 hundredths, which is the same thing, but gives me this 0 that I can look at. Because 6 goes into 30. 6 goes into 30 5 times. Exactly. And then I have 0 left over. And my estimate's a little more than 4, so this is where my decimal belongs. So what you do when you need to continue your number is just add a 0. Instead of doing 3/10, do 30 hundredths or 300 thousandths or whatever you need to do in order to make sure that the number is big enough that you can divide into it. And we're going to look at F so that we can fill in the blanks down here. F is 103.2 divided by 11. And I'm going to estimate that it is between 9 and 10. Because 11 times 9 is 99, and 11 times 11 is 121, so it's somewhere in the middle of that. So, between 9 and 10. And it's 103.2 divided by 11. 11 goes into 103 9 times, that's 99. When I subtract, I get 4, which is smaller than 11. I can bring down my 2. 11 goes into 42. 3 times, which would give me 33. And I subtract, and I get 9. Yeah. And, because that would be 12 minus 3. Anyway, I need to add a 0, do 20 hundredths instead of 2/10. Bring down that 0. 11 goes into 98 times, which is 88. And I'm going to get 2 left over. Bring down a 0. 11 goes into 20 one time. And it would have, that would be 11, so it would have 9 left over. It goes into 98 times, so we would get this repeating decimal. I kind of ran out of room. So let's make that really clear by giving more room to our problem so that we can see what happens here, because this number kind of starts to repeat, but we need more room to be able to see it. I'm going to go ahead and add my zeros, because if I add zeros, I'm not changing the number. I'm just giving myself more room to divide. So that's 9, 42, 9, 8, 1, get 11 with 9 left over, 8, we get 88 with 2 left over, bring down the 0, we get 20, and that would be another 1, and 1 times 11 is 11, 20 minus 11 is 9, so we get this repeating pattern where it's 90 minus 88 is 2, 20 minus 11 is 9, 90 minus 88 is 20. So it repeats forever and ever and ever. 8, 1, 8, 1, 8, 1, 8, 1, 8, 1, 8, 1. And it needs to be between 9 and 10, so it's 9.381818181. And the way that we show that is either by I'm going to pause there. We have a repeating decimal. We can round these. So I could round it to 9.38 or to 9.382 because that 8 would tell me to round up here. Or we can mark them with a line over the repeating digits. So the 8-1 repeats, so I'd put a line over that like this to show that the 8-1 repeats. That's how we treat repeating decimals. Now, what happens to whole numbers when they have a remainder? And this is just the same thing we were doing, but now those already had a decimal, and this one we are adding our own decimal. So this is 12 divided by 5, which is going to be more than 2, but less than 3. So 12 divided by 5. Well, 5 goes into 12 2 times, which would give me 10. And I get 2 left over. Now, I could say that this is 2 2/5 because I have 2 left over out of the 5 that each group is made out of. So I could do that as a fraction, but I want to use a decimal because that's more consistent. That's what more people use. So what I'm going to do is I'm going to add a decimal and a 0 because 12 is the same as 12.0. Those are the same number. So adding that decimal doesn't hurt anything. And I carry it down that 0, and 5 goes into 20 4 times with nothing left over. So it's 2.4. And I said, remember that this is 2 2/5 if we just use the remainder. Well, 2 4/10 is the same as 2 2/5. If you remember our equivalent fractions lessons, if I multiply it times 2 on the top and the bottom, then I get 2 4/10. Same thing. One more example, 100 divided by 8. It's going to be somewhere around 12, a little more than 12, because 12 times 8 is 96. So I do 100 divided by 8. 8 goes into 10 once. 8 goes into 20 twice. 16. We have 4 left over. We don't want a remainder. This would be 12 4/8 or 12 1/2 because 4/8 is a half. This is half of what I have. I've been dividing into groups of 8, and I have 4 left, so half of a group. So that makes sense. Anyway, I add a decimal and a 0, and I keep going. And 8 goes into 45 times. Exactly. So it's 12.5. And 0.5 means half. So there you go. And we can also divide smaller numbers by bigger numbers this way. So this is the same as 1/4. So whatever 1/4 is equivalent to as a decimal, that should be our answer when we divide this. I'm just going to estimate less than 1 because 4 doesn't go into 1 even one time. This is 1 divided by 4 because I said even though this number might be smaller, the first number always goes in the house. 4 doesn't go into 1, so I have to add a decimal. 4 does go into 10, goes in twice, which is 2 times 4 is 8. 2 left over, add another 0. 4 goes into 25 times. And 4 times 5 is 20, so it's exact. And I can stop. So it's 0.25. And 25%, 25 hundredths, and 1/4 are all the same. So that's where that comes from. Then there's just some practice, and the homework is more of the same. So that's dividing decimals in a nutshell. Hope you found that helpful.